1972, a crack commando unit was sent to prison by a military court for a crime they didn't commit. These men promptly escaped from a maximum security stockade to the Los Angeles underground. Today, still wanted by the government, they survive as soldiers of fortune. If you have a problem, if no one else can help, and if you can find them, maybe you can hire
Mr. Moore! And welcome to Mr. Moore's online flip classroom, and boy am I excited to be here today because it feels like an eternity since I was last in front of this camera teaching you all about mathematics. Now in this brand new series we're going to look at exponential and logarithmic functions. Those are essentially graphs that go up or down like this, as you can see. Alright, so what we're going to do though before we go any further is we're going to have a look at some of the basic stuff to do with it. And that is basically your index laws. Alright, we need to be able to work with these so that eventually we can go through and sketch the functions of these graphs. So let's now have a look at some of the stuff that we'll need to know when working with index laws. Let's check it out. Cool! Alright guys, so there's a few things that we need to know when working with exponential functions, or in this case, index laws. Now the very first thing that we need to be able to do is recognize when something's exponential. Now when you get something that looks like this, that is a to the power of x, this means it's exponential because you've got your base here, that's your a, and then you've got it to the power of x. So x is your power. So your base is a and your power is x. Now when working with these, there's 8 simple rules that we need to follow in order to be able to simplify them. And I call these
the Big 8.
The Big 8. Let's check out the very first example of law number 1.
Alright, so today we're going to have a look at how to simplify index expressions using index laws, or something that I refer to as the Big 8. Now what we're going to do is we're just going to go through one index law at a time, then I'll get you to have a go at a few questions, we'll stop there and then we'll come back to the next index law. Alright, so the very first index law states that if you have m times a to the power of n, this is equal to am plus n. Now in English what this basically means is if you have m squared times m to the power of 3, this will be equal to m to the power of 5. Now if you're like me and want to know how this works, well this is because if you've got m squared times m to the power of 3, well that's going to be the same as saying m times m, because that's m squared, times m times m times m, because that's m cubed. And when you go m times m times m times m times m, well how many have you got? Well you've got m to the power of 5, and that there is how that works. So basically going to this now, what I want you to do is just press pause and attempt the following questions. There's 3 to the power of 6 times 3 to the power of 8 times 3 to the power of 4. And for B, m squared n to the power of 6 p to the cubed times m cubed n to the power of 5 p to the power of 7. And for C, 4x squared y cubed z to the power of 5 times 2y cubed x to the power of 4 z squared. Remember when you're done to press play so you can check your answers out against mine. Alright, so welcome back now. So if we've got 3 to the power of 6 times 3 to the power of 8 times 3 to the power of 4, well what I need to do is essentially just grab each one of these powers that you can see that I'm highlighting here and add them together as you can see here. So I get 6 plus 8 plus 4, which is actually equal to 3 to the power of 18. Coming over to this one now for B, you've got m squared n to the power of 6p cubed times m cubed n to the power of 5p to the power of 7. So what I need to do is look for the things that have got the same base. So as you can see I've got m and m here, so you've got 2 and 3, so I go m to the power of 2 plus 3, n to the power of 6 plus 5, because the n's are the same, 6 and 5, so n to the power of 6 plus 5 that you can see here, and then p to the power of 3 plus 7. P to the power of 3 plus 7. So if I go through and simplify that, m to the power of 2 plus 3 is equal to 5, n to the power of 6 plus 5 is equal to 11, and p to the power of 3 plus 7 is equal to 10. So I get m to the power of 5, n to 11, p to the power of 10. Now for part C, if we have a look, I've got 4x squared y cubed z to the power of 5 times 2y cubed x to the power of 4 z squared. So I go through and have a look at which ones have the same base, and also I'll look at my numbers. So if I have a look at, first of all, I've got 4 and 2, so I write 4 times 2 out the front like you can see here. Then I go x squared x to the power of 4, so my x's are the same base, so you go 2 plus 4, x to the power of 2 plus 4. Y cubed y to to the power of 3, so it's y to the power of 3, y to the power of 3, so you go 3 plus 3 as you can see here, down here, and then you go z to the power of 5, z to the power of 2, so it's 5 plus 2. So that gets me 4 times 2 is 8, x to the power of 6, y to the power of 6, z to the power of 7, because 2 plus 4 is 6, 3 plus 3 is 6, and 5 plus 2 is 7. And that there is how you work with index law number 1.
Cool, so we've just had a look at index law number 1. Now let's check out how to work with index law number 2.
Alright, so it's time now for law 2, and this states that a to the power of m divided by a to the power of n is equal to a to the power of m minus n. Now, in basically layman's terms, what this means is if I have m to the power of 5 and I divide it by m to the power of 3, that's going to be equal to m to the power of 2, because 5 minus 3 is 2. Now let's just quickly see how this works. Well, if I've got 2 to the power of 5 and I divide this by 2 to the power of 2, well, I could write that as 2 times 2 times 2 times 2 times 2, because that there is 5 lots of 2's, divided by 2 times 2. And then what I get is I've got 1, 2 here, and I can cross these two off, leaving me with 2 to the power of 3, or 2 times 2 times 2 is 2 to the power of 3, which is equal to 8. So now what I want you to do is just press pause once again and attempt the following questions. That is 2 to the power of 6 divided by 2 to the power of 4, m to the power of 7, n to the power of 8 divided by m squared, n to the power of 6, and x to the power of 10, y to the power of 12, z to the power of 7 divided by x to the power of 4, y to the power of 3, z to the power of 5. Remember, when you're done, to press play and check your answers out against mine. Alright, so welcome back now. If you have a look here, it says 2 to the power of 6 divided by 2 to the power of 4. So because it says divided by here, what I'm going to do is 6 minus 4, as you can see here. So therefore I get 2 to the power of 2, which is equal to 4. Coming over to this one now, I've got m to the power of 7, n to the power of 8, divided by m squared, n to the power of 6. So look at the ones with the same base, which happens to be the m and the m. So I do 7 minus 2, because it's a division sign, so 7 minus 2, and I do 8 minus 6 for the n, because it's the same base, so n to the power of 8 minus 6, which is equal to m to the power of 5, n to the power of 2. If I come over here now, I've got x to the power of 10, y to the power of 12, z to the power of 7, and x to the power of 4, y cubed, z to the power of 5, remembering this means divided by. So I go my x's here and here, so therefore I go 10 minus 4, as you can see here. My y's have got the same base, so I go 12 minus 3 for this one. And then I go z with the same base here. I go 7 minus 5 as you can see here. So therefore I get x to the power of 6, y to the power of 9, z to the power of 2.
Index law number 3.
Now rule 3 states that anything to the power of 0 is equal to 1. So therefore if I have a to the power of 0, I end up getting an answer of 1. So in English, what does this mean? Well, if I've got 7 to the power of 0, well, that means 1. Alright, so what I want you to do now is actually press pause and attempt a couple of questions on your calculator just to check to see if this is the truth. So I want you to do 5 to the power of 0, and I want you to do 10 times 4 to the power of 0. And do those on your calculator, press pause right now, and then when you're done, come back and check your answers out against mine. Alright, so welcome back. Now hopefully what you did on your calculator was you got 5 to the power of 0 is equal to 1, and 10 times 4 to the power of 0, well that's also equal to 1, because 10 times 4 is 40, and when you put that to the power of 0, you get the answer of 1. Using another example, if I did Mr. Moore to the power of 0, I should also get 1, because everything that you do to the power of 0 is equal to 1. Now what I want you to do is press pause once again and attempt the following questions. That is 10 to the power of 0, 5 times t to the power of 0, 3x all in brackets to the power of 0, and 4 times 12xy in brackets to the power of 0. Remember, when you're done, to press play so you can check your answers out against mine. Alright, so welcome back. Now as you can see here, I've got 10 to the power of 0, so the 0 goes to the 10, so 10 to the power of 0 is equal to 1, because anything to the power of 0 is 1. Now for this example, my 0 only goes to the t, because it's only the t that's to the power of 0. So therefore, my t to the power of 0 is 1, and I've got 5 times t to the power of 0, so I get 5 times 1, and that therefore is equal to 5. Come down to this one now, I've got 0, and the 0 actually is to everything inside this bracket, so it doesn't matter what this is equal to, because when I put it to the power of 0, I get 1. And my final one, I've got 4 times 12xy to the power of 0. Now anything inside this bracket, doesn't matter what it's equal to, because when I put it to the power of 0 I get 1, so I get 4 times 1, which is 4.
Oh, the camera's on. Index law number 4.
Now law 4 states that if I've got a to the power of m inside brackets and then I put it to the power of n, what that gets me is a to the power of m times n, or a to the power of mn. Now basically what this means is if I've got p to the power of 2 inside brackets and then I cube it, I get p to the power of 6. Now how does this work? Well, if I've got, for example, 4 to the power of 2 and then I want to cube it, what I'm going to get is I'm going to get 4 times 4, because that's 4 to the power of 2, but then I'm going to multiply it by itself 3 times, so 4 times 4 times 4 times 4, because that's 4 to the power of 2, 4 squared, and then I cube it because it's the same thing 3 times. Now what's that going to get me? Well, it's going to get me 1, 2, 3, 4, 5, 6, so 4 to the power of 6. Oh, that's right, 4 squared to the power of 3 is equal to 4 to the power of 6, because you multiply the numbers there. So what I want you to do now is press pause and attempt the following questions. That is 10 squared to the power of 3, p squared to the power of 6, and 3 times m squared to the power of 4. Remember when you're done to press play and check your answers out against mine. Alright, so as you can see in this example, I've got my base 10 and I've got that to the power of 2, and then I put that all to the power of 3. So what I do is I multiply my 2 times my 3, so it gets me 10 to the power of 2 times 3, which is 10 to the power of 6. The same deal here, so I've got p to the power of 2 and then put it to the power of 6, so I just multiply the 2 and the 6, so it gets me p to the power of 2 times 6 is p to the power of 12. Now this one's a little bit more challenging, but not too much, and you've got 3 times, in brackets, m squared to the power of 4, so you do the 2 times 4, and you leave your 3 times out the front, so you get 3 times m to the power of 2 times 4, which is equal to 3 times m to the power of 8, or 3m to the power of 8.